Welcome back to our channel, where today we're diving into episode 11 of our series on creationism versus evolution, focusing on the challenges faced by the mutation model in evolutionary theory. Today's episode is titled, The Shortcomings of the Mutation Model, a Lack of New Information. Mutations are variations of existing genetic codes or random combinations, neither of which can provide new information. The first type, being a rearrangement of what already exists, is inherently limited in its outcomes. The second type, completely random, lacks the ability to produce complex information or new functions that did not previously exist. While random changes in dimensions, density, location, and similar characteristics can occur, truly novel attributes, like those distinguishing different species beyond superficial traits, such as a giraffe's long neck, which involves specialized systems, cannot arise from random combinations alone. The initial cell's creation is a separate issue, but mutation is a cornerstone of the theory. The idea that random combinations could consistently create organized commands billions of times is implausible. Random changes do not become functional commands, especially when they introduce a new element that didn't exist before. Indeed, playing with existing genetic material and incorporating random changes might theoretically explain minor variations between species. However, this is so improbable that it has never been observed, making it an insufficient basis for explaining the diversity of billions of species and their traits. Warren Weaver noted in a report on the genetic effects of nuclear mutations that, practically speaking, all known genes that have mutated are harmful. As we delve deeper, seeking evidence that such mutations could account for the vast differences between species, we find none, not a single instance. This raises the question of how consciousness, love, anger, pride, compassion, and excitement can arise without an information source. No example of mutation adds information. A classic example of mutation in our time is the adaptation of bacteria to antibiotics or insects to pesticides. Biophysicist Professor Lee Spetner describes two mechanisms through which bacteria have developed resistance to antibiotics: horizontal gene transfer and identification loss by the antibiotic. Horizontal gene transfer is the spread of an existing gene absorbed by a new organism, which is irrelevant to the creation of a new gene. Identification loss impairs the antibiotic's ability to recognize the bacterium, which does not require the production of a functional substance for evasion. A mutation-induced change suffices for the antibiotic to fail in recognition. This is akin to a person being exempt from military service due to a mutation causing the absence of a limb, a mutation that provides an advantage, but not a physical improvement for the species. Biologist Francisco Ayala states that the genetic variations required for resistance to many types of pesticides pre-existed in all individuals of populations exposed to these man-made compounds. The mutations necessary for macroevolution have never been observed. No information has ever been added through random mutations that would represent those required by neo-Darwinian theory and examined at the molecular level. The question is whether the observed mutations support the theory, and the answer appears to be no. Spetner. The famous example of the peppered moth, which became darker due to natural selection, is a classic case of evolution in action, based on experiments by British biologist Bernard Kettlewell. The moth changed from light to dark, thus surviving because its camouflage matched the new environmental conditions. Trees turned black due to industrial soot. However, this change is minor and did not result in a new organ or species. It was merely a color shift. The selective advantage of this change does not depend on the function of the change. The color serves no purpose other than matching the background color, providing camouflage. This is similar to the advantage gained by a person born with a defect, exempting them from military service. Moreover, there's no evolution here, as the dark moth existed prior to this shift and simply proliferated at the expense of the light moth, with no mutation involved. The light moth did not disappear but became less common. Molecular biologist Jonathan Wells offers a more accurate description. Subsequent experiments showed that only one type of moth rests on tree trunks, while others prefer to rest under small horizontal branches. Since 1980, it has been clear that the peppered moth does not typically rest on tree trunks. Decades of fieldwork by scientists such as Cyril Clarke, Rory Howlett, Michael Majerus, Tony Liebert, and Paul Brakefield concluded that Kettlewell's experiment forced the moth to behave atypically, hence its results cannot be considered scientific. Further, despite expectations that the light moth population would be higher in less polluted areas of England, the dark moth population was 4 times larger, suggesting no correlation between moth population and tree bark, as claimed by Kettlewell and almost all evolutionary sources. The controversy deepened. Peppered moths on tree trunks, photographed by Kettlewell, were actually dead specimens pinned or glued to the trunks, making true observations unlikely, since moths do not typically rest on trunks, but under leaves. Though this is just one example and should not be dwelled upon excessively, it has always served as a cornerstone in introductory evolution courses. The discoveries in the late 1990s caused significant discomfort. Jerry Coyne remarked, "My own reaction reminds me of the shock I got when, at the age of 6, I discovered that it was my father, not Santa, who brought the presents on Christmas Eve." On a related note, Libowitz commented, "The question of how chemical changes in a gene type cause morphological or functional changes in the phenotype, which are not merely chemical, and sometimes not chemical at all, but manifest as hereditary changes in the organism's constitution, remains unanswered. Today, we lack a scientific theory or even a plausible hypothesis that integrates this question with the general knowledge in the natural sciences." Thank you for joining us for this deep dive into the complexities of mutations and their role in evolutionary theory. Stay tuned for our next episode, where we'll explore another fascinating aspect of the creationism versus evolution debate.